as we have studied until now, that classes have data members and member functions. So the data members and member functions are normally called instance data members and instance member functions. There is another category which is called static data and static member functions. So what's the difference between that? Let's discuss this. So the instance data members, the normal data members and member functions are such members which which is which each object have its own copy. So we declare the data and the functions, but when we create the object, then every object has its own copy. For example, like this one, if we have a class, okay, and that class has a length and width data members, okay, so these are instance data members. So if we create two objects, one box one and one box two, then both has the width and length, but its values are different, so its copy is different, and the same width have a different copy with a different value in box two. The same goes for length. So meaning to say instance data members and instance member functions are such members which each object has its own separate copy. So and then any operation applied by that object, the object can only modify and apply operation on its own copy. It will not affect the width and length of other objects. On the other hand, there is another category which is called static data members. Okay, static data members are such members, such variables inside a class which is shared by all members, all objects of the class. The same goes for static member function. Static member function is also shared by all objects, but actually it is in such a way that it can be used to access static data from member variable. So if once we define static variables, then we can define static functions to access the static variables. Okay, and can be called before any objects are defined. This is a very important point. Most of the times in a questions, this questions is asked. Okay, what is the name of functions which can be called before creating any object. So this is the static member functions. So how to define these static data members and static member functions, and how to call it. Just as an example, you see, if this is like, let's suppose we have a tree class, and the tree class has one static int object count variable. So this is static variable now. It is not instance variable. So this is a normal constructor. Okay, normal normal non-static function. Okay, not the point now that you see the static variables can be initialized and must be initialized outside the class before going to create any object. The way to initialize is like this, that it's data type, and then the class name, and the scope resolution operator, and uh, uh, the static variable name, and then its value. So you see here it is just initialized, it is initialized just after the end of the class. So it, static variables and static functions can be accessed through a class name and scope resolution operator. There is no need for functions are there is no need of objects to define objects first and then use the getter and setter functions and access it. No, static data and static member functions can be called without objects, just using the class name and scope resolution operator. So you see here, if in a main function, uh, there are three objects are created. Okay, so when three objects are created, then each time the object count was incremented in the constructor, and the object count was static member. So each object has the same copy, not different copy. So this is why when we display that object count value, then it will display 3 because 3 objects are created. So in one constructor, it will be plus 1, second constructor again plus plus, then become 2, third constructor again plus plus, then become 3. And if you call this one with any object like get object count, this is a non-static function. So this is why we are calling with object. So if you call with any function, it will display the same value 3. So it is like this. So you see the object count, it is a static variable. So actually the variable is 1 and each object is sharing the same variable. So any change here will reflect here also, will reflect here also, and will reflect here also. So static data members and static member functions are such functions which are shared by all objects of that class. So these are mostly used in a gaming functions. For example, in a game, if there are a multiplayer game and the games are played in a group, for example, nowadays there are several many games like this. So for example, this is group A or team A, and this is team B, and 3 players from there, 3 players from here. So you see, these 3 will be the objects, okay? Objects of team A, let's suppose, and these 3 will be the objects of team B. But what they are sharing, so they are sharing, let's suppose, the victory, okay? The victory is shared by all these 3. So these 3 will win or lose together. So the victory and the loss is shared by all 3 of them. So in such cases, we need static variable. The same goes for these 3. So if you look at this one, everyone individual life, the individual life is separate. Okay, let's suppose this one die. Okay, this one die. So it doesn't mean that this one will also die because the life value is its own instance data, and instance data is a separate copy. It doesn't affect this one. But the victory is a shared information, and if this one loses, okay, then the rest two will also lose because they are sharing this information. So in such cases, we need static variables. Static member functions we can declare like this, that you see we will use the word static and then the return type and then the function name. Okay, and if this function is not changing any value, then you can define as a constant also, and then simply return the count type. But when you are calling this function outside the class, okay, or in main, then you see we are calling with class name, not with any object name. Okay, and this function will access only the static data members because it cannot access instance data members, because instance data members are specific data, specialized data to each object, and that can be only accessed through object, not by class. But in this case, we are calling through the class. So through the class is shared among them. So only such data which is shared among them can be accessed through static functions. Okay, a simple example is like this. That let's suppose we have the same tree class, okay, and static data member. This is normal constructor. This is static member function, and it uses the same static data member. So now when we want to call it, so the way of calling is like this: a function, then scope resolution operator, and then the function name. Let me show you one example. Let me show you one example of static data members and static member function. Okay, so let's define a class student. We did it on this then easy value student. This is the structure of the class. Now private. Okay. in object count. Here I will use, let's suppose, student count. Student count semicolon. This one should not be colon. This is semicolon. Okay. So very simple one. We will use public. Okay. Uh, and here in public section, we will define a constructor student. And inside this constructor, we will simply uh, increment the object like student count plus plus. So whenever object is created, constructor will be called and its value will be plus plus. But its value should start from where the initial value initialization. We cannot do initialization inside class. We will do this outside class. So how to do? I will show you. Another function. Let me first declare a simple function and then later on we will change to a static function. So int get count, let's suppose, and this one I will simply return uh, student count. Okay, return student count. So that's all to be simple. Now let's come out of the class. You see, class ended already here. Now I'm out of the class, and here I am typing. I'm initializing the static variable. So how to initialize? It's type int and then the class name student. Okay, and then scope resolution operator, and then student count is equal to 0. Let's suppose start from 0. So the initial value, you see, we will initiate. So this 0 will be stored somewhere in a memory. So this will occupy some memory. This is why uh, we are declaring outside, initializing outside the class, because as a definition of class is just a blueprint. It's just uh, uh, a structural definition, but it doesn't occupy any memory. This is why we cannot initialize a static data members inside a class. So we will define outside the class. So whenever we define outside the class, then we need class name and scope resolution operator. Okay, now to test that different object is sharing the same variable. So let's create three different students. For example, a student. One is, let's suppose, Ali. Second one is a city. Third one is, let's suppose, Zulaiha. Zulaiha. Okay. So we know that when object is created, constructor will be called, and when constructor is called, it will increment the student count, and the student count is a static data member, so it will be shared by all object. So when it is count, it is plus plus, so it will become 1. So every object will get the value 1. And when the second object is created, okay, then again it will be plus plus, then it will get, both of these two will get the value 2 because they are sharing the same thing. When third one is created, then the constructor will call again and it will become 3, and then all these three will share the same copy, whose value is 3. Okay, so now if we want to display what is the value stored now in this one, so we can do like this, because it's a return a value, so we will display cout just the static variable value is equal to. So to call this function, you see, this is to get its value, we have a non-static data member. So we can only call this function using any of these um, uh, any of these objects. For example, if I call with ct dot get count, okay, so I am calling with ct dot get count, but it will display its the value which is shared by all of them. So let's save it and run it. So you see the value of static variable is 3 because we have 3 data members. So if you call this function with any object, for example, if I this time I'm calling with Ali, so save again, it will give me the same result again, the value 3 because uh, the same value is shared by all 3 of them. Okay, it is a static data member. Now, if we want to change this function to static function, then how to use it? Okay, so we can use like this static int get count. Now, when we want to call this function, now it's a static function. We cannot call with object name with any object. Now we will call with class name, which is student. Okay, okay, student dot get count. But you see the data operator is used with object. With class name we will use a scope resolution operator. Okay, so when you are using class name, then you will have to use scope resolution operator. Like here in the initialization time also, we are not using data operator because data operator is for object, not for class, and these are static data members we can only access through the class name, not with object name. Now, so you see, when we call this one, so you see, we are not calling with any specific object, we are calling with through a class, so it will again display the same value. See, the static variable value is 3. So this is the concept of static data members and static member functions. These two members, which may be data members and function members, but these are such members which are shared by all the objects. Okay, other than that, the instance data members and instance function members, uh, each object has a separate copy, but static data members and static member functions are shared by all objects.